Okay, this is section 1.7, transformations in the coordinate plane. Our goals are to identify reflections, rotations, and translations, and graph transformations in the coordinate plane. A transformation is a change in the position, size, or shape of a figure. The pre-image is the original image, and the image after the change is called image. Okay, so a transformation maps a pre-image to an image. So, for example, we could have this triangle ABC right here. That could be our pre-image, and then the image could be right here. So what did I do to this triangle to get it to appear here? I moved it. I shifted it. Right. You could say, how did I shift it? Well, maybe I shifted it a certain distance to the right and a certain distance down. Does that make sense? But this would be some kind of a slide transformation. Okay?
All right.
And then what we can do is we can say, listen, this is ABC, triangle ABC, is mapping onto a new triangle. And we write this like this, and we call these primes. So A prime, B prime, C prime. So this is the pre-image, and this is the image. And I put a little arrow saying the pre-image is mapping to the image.
So whenever you see those lines, that means it's the new image?
The new one is going to have the little prime saying A now becomes A prime, B becomes B prime, and so on.
What does like prime mean?
Prime just means that's just the notation that mathematicians use for that. All right, so here are the 3 different types of transformations that we're going to be studying in this section. We have reflection as one type of transformation. You could refer to a reflection as a flip, but good, serious mathematicians like all of you will use the word reflection instead of flip. Well, the mirror would really be the line of reflection. It wouldn't be the transformation itself. Does that make sense? Because mirror is kind of a noun. Well, I guess mirror could be a noun. Let's go with reflection. Yeah. Okay. So a reflection is a transformation across a line called the line of reflection. You could call that line of reflection a mirror if you'd like. Each point and its image are the same distance from the line of reflection. So, for example, if this line here, I'll call it, let's just say that was the y-axis, for example, right? Then the distance that point B is from this axis is going to be the same distance that B prime is from the axis, right? Because the point B has been reflected over this y-axis to get that new point. So these 2 segments, if you will, would be equal. Same thing with point A. The distance that A is from my axis is going to be the same as the distance that A prime is from it. Does that make sense?
Wait, did we do this last year?
Pardon me?
We did this in degree algebra.
Possibly so. Transformations are, ask anybody who's in Algebra 2 right now, transformations are a big part of Algebra 2. Big part. Okay, next one is rotation. A rotation or a turn is a transformation about a point P called the center of rotation. And each point and its image are the same distance from point P. So often in geometry you will see some kind of a rotation like around the origin. So something might get rotated around the origin, and it basically looks like it's been turned, it's been rotated, okay? So that is our second type of transformation. And our third type of transformation is a translation, which you could call a slide, okay? And in that, all the points of the figure move the same distance in the same direction. So for example, as I said, you might take this pre-image JKLM and slide it this way right here. But to get there, we're probably going to have to say, oh, let's slide it 8 units to the right and 3 units up, or something like that, to accomplish that slide transformation. Okay? Moving on. So in this case, it says identify the transformation. Use arrow notation to describe the transformation. So this is really asking you to do two different things. First, can we identify the transformation? Is this, I'll go back to our answers here, is it a reflection, a rotation, or a translation? What do you think here? Is this a reflection, a rotation, or a translation? I should get my popsicle sticks though. Popsicle it up. Okay, Olivia.
It's a reflection.
A reflection. Why do you say so?
Oh, wait. Oh, no.
You're changing your mind.
Wait, yeah, it is. Because,
You're changing your mind back again.
yeah, could you flip it?
So you're saying E is ending up over here, F is kind of ending up over here, G. So if you picture that there is a mirror, right here, right, our axis of reflection here, then it sure looks like E got mapped over to here, F got mapped over to here, right? So this is a reflection. All right, that's this answer to here, to identify the transformation. Now for this part, where it says use arrow notation, that's just when you're going to say, you know, I've got E, F, G, and that's mapping onto E prime, F prime, G. That's all you have to do to use arrow notation in this particular problem. What about this example? Let me slide this down here. What kind of a transformation does this look like here? Andrew?
Rotation.
Rotation, why do you say so?
Because it rotates and
Trying to rotate is at because it's not just moving, it's actually rotating as you're, you know what I mean? It's actually, I'm trying to do it in slow-mo,
it's like a ball.
right? Does that make sense? So it's rotating like this, okay, as we go. So I would agree that this is a rotation. And then our arrow notation, use arrow notation to describe. What would you write for that, Angelina?
TRS, and then it's going to use the line T,
UTRS is going to U prime, T prime, R prime, S prime.
Does it matter?
Are we
what
okay?
word?
Yeah.
That's a great question.
I was
That's a
looking
great
at-
question.
well, and I sit down.
Oh, come on.
So the answer is it does not matter what letter you start with here. When you name a polygon, though, you do have to go around either clockwise or counterclockwise. In other words, I could name this RSTU, that's okay. But I could not name it USRT, because now I'm not going consistent, right? I'm bouncing across and so forth, so this would be no good. And if I did name it RSTU, I would have to say it maps to R prime, S prime, T prime. I got to keep those consistent here and here. Okay? Rachel?
I was gonna ask if it mattered, like, the pi, TRS had to go first or not? Like, or had to go last, like, does it matter?
Has to go last, because this is representing our pre-image, and this is our image. And we're having a little arrow saying we're starting here and it's going to this. Okay?
For reflection, rotation, and translation, are they just written, like, the same way as the time thing?
All written the same way. Yes, all same kind of notation for that. Okay, so let's take a look at this. A figure has vertices at, let's get this a little bit bigger here, at -1, 4, -1, 1, and 3, 1. After a transformation, the image of the figure has vertices at, and it gives 3 new order pairs. Would you please take 30 seconds to plot the first triangle? This is our pre-image, so -1, 4, that's point A. negative 1, 1 is point B, and 3, 1 is point C. Do people agree with this?
Yes.
Go ahead and connect these, because the figure has those as its vertices, which means this must be a triangle. Are we okay with this?
Yes.
All right, and now we want the image to be, I'm doing that one in blue here, so if I'm going to do negative 1, negative 4, I'm calling this point A prime. Everybody with me?
Yeah.
Oh,
And then negative 1 is here. This is going to be B prime. And 3, negative 1 here is going to be C prime. And I can connect those. All right, and you are supposed to draw the pre-image and the image. We did that. And we're supposed to identify the transformation. What do you think, Maya?
It's a reflection.
It's a reflection. Reflection over what?
Over the x-axis.
Yeah, reflection over the x-axis. Are we okay with this?
Yeah.
This x-axis here was like our mirror, like that's our line of reflection.
I think you should get a pen.
All of these should get flipped over here like this. All right, let's keep going. So, at this point, for this next problem, you are given a rule for the transformation that you need to follow in order to find the image. Okay, they're giving you the pre-image here, ABC. All right, and now you want to follow the rule that says,
We don't have the pre-image.
On our
Draw it then, guys.
oh my goodness, please plot negative 1, 1 for A. This is negative 1, 1. This is 1, 2, 3, 1, 2, 3. Negative 3, 3 is B. And C is negative 4, 0. Do you have that plotted?
For arrow rotation, won't we always be right? It's the same thing for all three of the sides.
I don't know if you'll always be right, 'cause maybe you'll get your letters mixed up, or maybe you'll forget to put primes or something, you know what I mean? But it's pretty straightforward. Yes. Okay, so with this rule now, everybody has this graphed?
Yeah.
Okay, with this rule, we want to use this translation. They're even giving you the hint that it's a translation, not a reflection, not a rotation, right? And so we're going to use that to come up with our new ordered pairs. So let's take our pre-image, I'll say pre-image ordered pairs, and I want my image ordered pairs. And I'm going to start with my first pre-image order pair was A, and I'll just put A, and that's negative 1, comma 1. So that means I'm going to put it into this little machine, if you will, where it takes every x and adds 3 to the x, and it takes every y and subtracts 4 from the y to get our new point, which I'm going to call a prime, and that new ordered pair is going to be what, Elizabeth?
That's the 2, and then 2.
Let Elizabeth answer.
And 3.
Oh, how did you get 2 and how did you get negative 3?
Because when you do negative 1 plus 3 is 2,
So we have to add 3 to the x,
and then
negative 1 plus 3 is 2, and then you had to do what?
1 minus 4.
Minus 4 from the y. So 1 minus 4 gives us negative 3. So that gives us a prime, right? Which is at 2, negative 3 is right here, is a prime. All right, how about point B? That point was negative 3, 3. And so B prime is going to be where? Evan?
It's gonna be 0, negative 1.
0, negative 1. Do people agree with that?
Yeah.
We're following this rule that says subtract 4 from the y, and it says add 3 to the x, so negative 3 plus 3 is 0, 3 minus 4 is negative 1. Are we okay with this? And so I'm plotting b prime at 0, negative 1, that's right here, b prime. And then how about point C? C was negative 4, comma 0. So where is C prime going to be? Nathan May. Negative 1, negative 4. Do people agree with that?
Yes.
Because we take and we add 3 on to the negative 4, that gives us negative 1, and we subtract 4 from the 0, the y coordinate, we get negative 4. So I'm plotting that one, negative 1, negative 4 is right here. And so if I draw this in,
No,
yes? Does that look right?
Yes.
And so what we're doing is we're taking this pre-image and we are sliding it 3 units to the right, 1, 2, 3 units to the right, and 4 units down. 1, 2, 3, 4. Are we okay with this?
Yeah.
On the quiz, we have to say like how many we're moving over and down.
You may have to give a rule that fits an image and its pre-image.
Oh, like x is plus 3.
You might have to write something like this yourself, or follow it, right? Either way. All right, let's take a look at what's next. Right, like this, for example. Write the mapping. When it says write the mapping, that's you saying, let's see, x, y is mapping to what? Does that make sense?
Yeah.
Yeah.
And you need to use arrow notation. That's when we say Hij maps to H prime, I prime, J, right? J prime. That's the arrow notation. But do you have this picture on your notes?
Yeah.
Okay, so take 30 seconds, please, and reason out what the rule would be, or the mapping. All right, so what do you think? What do you think this rule is going to be, this mapping? Isabella?
I didn't finish it yet.
Well, what are you doing so far? What's your thought process?
So far, I wrote down the points of each letter.
Okay, so what ordered pairs did you have for the pre-image, which is this guy right here, right?
For H, I have 3, 3. For I had 4, 4. And for J, I had 2 and 5.
2 comma 5?
Yeah.
Everybody okay with these?
No, shouldn't it be 5, 2?
Oh, yeah.
Is it 2 5 or 5 2?
5, 2.
Yes.
5 2? Okay, and so now if we look at our image, then we have H where, or H prime I should say,
4, -1.
4, -1.
No, for
It
H,
should be -3, -1.
yeah, it should be negative.
Oh, no.
So H is -3, H prime is -3, -1. How about I prime?
0 and
No, it's -2.
yeah.
Oh, let's figure it out.
-2, 0.
-2, 0. And how about J prime?
-1, -2.
Do people agree with these?
Yeah.
Okay, so take 15 seconds, talk to the people around you. Can you agree on what the rule is going to be to get from these previous points to these points?
Oh, yeah.
I get 4 minus.
So X -6 and Y. Yeah, you had to go from, you start from the line. Yeah, you started, you start with these or something.
Yeah, you're going into the negatives. Okay, got it. Yeah.
So that'd be 6, 4. Is that what you got?
Yeah, but it's negative.
Well, I'm so confused.
We lied. Okay.
It's the first one on the top right.
So you're saying that you
Oh,
need to
because this is the pre.
Yeah.
Yeah, that's great.
Okay, good.
So it's 6 -4 or
Oh,
negative,
you're going
is it 6 -4?
Okay, tell me what you think here, Alex.
I got X -6 and Y -4.
X -6 and Y -4. Do people agree with that rule?
Yeah.
Yes. Okay, and how did you get that, Alex?
I took one of the points and I subtracted. Well, I subtracted I, that's 4,
4, 4.
and I prime -0.
Y is 4, 4, and I prime is -2, 0. And then what?
I subtracted -2 by 4.
So I have to subtract.
Of course, subtract 4 by -2.
Oh, okay. So in other words, to get from 4 to -2, you got to subtract 6.
Yeah.
Okay. And to get from 4 to 0, we've got to do what?
Subtract 4.
Subtract 4. So that's why we would say X got to be subtracted by 6 and subtract 4 from the Y.
Wait, I don't understand how you get -6, because Y minus -2 is 6.
We're saying to get from this X coordinate to this X coordinate, what did we need to do? To get from 4 as an X coordinate over here to a -2 as an X coordinate here, we had to subtract by 6.
So how would you,
Connor's saying, I don't really like this method. And we have
no, this is
another
the method I
method.
tried to use.
Mitch, you got some other method?
Which kind, I looked at both the pages for this, I just counted over the left until it was, I used the non-prime, so just regular.
Okay, so you kind of didn't even use ordered pairs at all? All right, so what did you do?
Start at the H, and then count over to the left until you're right above the prime H.
All right, so you said start here at H and count to the left until you're right above H prime?
So then you get,
So that was 1, 2, 3, 4, 5, 6 units. So we had to go 6 to the left,
yes, that's negative.
okay?
And then you go down, that's also negative. So you get over to the H and that gives you Y.
So from here, you gotta see how far you have to go down to get to H prime. So you said 1, 2, 3, 4 units down. Okay, and so that's how Mitch reasoned that X comma Y is gonna have to map to X -6 because you went to the left 6. And Y -4 because you gotta take the Y coordinate and subtract 4 from that. you two are going to check Blackboard for this video, right? You're gonna check Blackboard for
Okay.
homework assignments, and I think both of you have multiple videos to watch.
Yeah.
And lots of homework to do to get caught up,
Yeah.
right? And next time you miss a day, you're not gonna wait until the next class to see me, you're gonna come in like the very next day.
Lion time.
Or mine.
Did you get that computer? Lion time.
Okay. All right. Great news. Yes.
Well, good luck, guys.
Instead of saying like the x, y is maps or whatever, x minus 6 and y minus 4, could you just say it's a translation, like to the left 6 and down 4, or no?
You certainly could use those words to describe it, but if they are saying write the mapping, then that is technically this. This is the mapping. Does that make sense?
Yeah.
So that's what you have to say. But if you had to describe to someone in words what's happening, you're right on. Okay, questions on this? Okay, let's try this example. It says write the mapping using arrow notation for the transformation.
I was so confused.
So wouldn't we start by saying, hey, DEFG is mapping to D prime, E prime, F prime, G prime? Agreed? Yes? But now you're going to tell me X comma Y maps to what? Talk about it with people around you. See what you decide. What's your name on it?
But isn't there 3 shapes here?
They overlap each other.
Yeah, look at the one on the boards. Probably it's colorful, so you can see it better.
Wow.
Because it's this. It's this pre-image right here. Right, that's my pre-image, and it's going to this image. Agreed?
Yeah.
Yes? So you got to describe what this transformation is here. Is it a reflection, a rotation, or a translation? Carlina?
I said translation.
Translation? Do people agree?
Yes.
Okay. If I'm just able to slide it across my smartboard and get it in the right place, that sounds like a translation, right?
So
Slide.
you have to do a reflection and get one of these equations too?
Do I have to do a reflection on this one?
No, but on the question.
Possibly.
No, but like we never went over a problem.
We can do one like that. We'll do one next. I know there's not one on it. You're using some of your Algebra 2 skills.
Is that right?
So you're going to have some negative in there, right?
Yeah.
Do you have a mapping yet?
Yeah.
A rule? What do you got, Elizabeth?
X is 0, y minus 2.
X, you said X minus 0?
X plus,
Well, I mean,
Or X plus 0?
I said X plus 0, yeah.
And then what?
Y minus 2.
Comma, y minus 2. Do people agree with that?
yeah.
Because you're saying don't slide this left or right at all, just.
Yeah.
Wait a second, where was my original? Was my original here?
Yeah.
Oh, it's down. Just slide it up. Oh, okay. Then it'd be plus.
I want to slide it up 2, so this should be a y plus 2.
Yeah.
Okay, so I would say, let's write our rule this way. X comma y goes to X comma y plus 2. Since it's X plus 0, we can just write that as X. If you want to write X plus 0, there's nothing wrong with that. It's just cleaner this way. All right? Are we okay with this?
Yeah.
All right, so let's try one more, because the question was, what about a what about a reflection? So let's see. If I have this, My content.
What about a rotation, Ms. Fessick?
We can talk about that one also. So if I have a figure here, let's say I have A, B, C here, and let's say it is getting reflected. What axis am I reflecting over?
Yeah.
All right, so this is A prime, that's C prime, that's B prime, everybody agree? So what would be the rule for this? X comma Y maps to what? What do you think, Carlina?
Would just be X negative Y?
X comma opposite of Y? Do people agree with that? Are we keeping the X coordinates the same? Like here, A was at 3, 1, and what's A prime's order pair? 3, negative 1. So did we keep the X the same?
Yeah.
Did we make the Y opposite?
Yeah.
So I think this looks like a pretty good mapping or rule for reflecting over the x-axis. What if I wanted to reflect this same ABC pre-image, but I wanted to reflect it over the y-axis? So,
That's easy.
Is it really?
Yeah, it should be negative.
and like this, over like this. So this one, what would the rule be for this one?
Negative X.
Reflection.
So we would describe it as a reflection over the y-axis, and then our rule for that would be x comma y goes to what comma?
Negative X.
Negative x comma y. Are we okay with this? All right.
Okay, so.
Yeah, put your name on the board, please.
Would it be wrong for like the actual like numbers like that, like how it's on 3-1, and then it goes to negative 3-1, and we just wrote I don't know where lower this.
I mean, we want to generalize, so we want to keep it, we can't list specific order pairs, we want it general for any order pair.
Okay. Okay.
Are we okay with this?
I don't think it. Wait, I don't get why it's negative X.
Well, let's think about that. Because this ordered pair right here was 3, 1, but now it's getting mapped over here, and A prime is at negative 3, comma 1. The X coordinate changed to the opposite, and the Y stayed the same.
Oh, okay. Okay. I get it.
Does that make sense?
Yeah.
Okay.
Yeah, because the X, yeah.
Yes?
I'm lucky.
Okay. One, let's see. I want to,
Do we have a worksheet and homework for this?
Of course.
yeah, but I want to try one more thing.
Oh, just trying one thing.
One more thing.
Still recording. Yeah, we're still recording. Hosting.
So let's see, this is 2, 1, and this is, let's see, 3, 4, 5, 6, 1, and then this is 6, 1, 2, 3, 4, 5, 6, 7, 8, 6, 8. Does that sound right? I'm just curious, what would happen if you used this mapping?
Be reflected over the line.
I don't know, try it.
Oh.
See what ordered pairs you would get. I want you to tell me what new ordered pairs you would get under that mapping. The XY goes to Y comma negative X. And do you have graph paper? Would you graph this, please? Looks like Elizabeth's already ahead of us, right? Elizabeth's graphing this? Awesome.
The Y.
Awesome. So you're plotting this on graph paper, and you're going to give me 3, oh, I better label these, huh? Let me call this A, I'll call this B, and I'll call this C. And I want to know what is A prime going to be, what's B prime, what's C prime going to be under this transformation.
I don't understand. So the quiz.
This we
Well-
used to do last year, it's like, can we use a calculator?
I wasn't in your class last year.
Or, sorry.
No, yeah.
So A was 2 comma 1. So what's A prime going to be, Connor?
1 negative 2.
Do people agree with that?
Probably not.
No, wait, no. Yeah.
The X is 2, the Y is 1, but I want to take the Y as my first, so 1 comma, I agree with that.
Wait, I don't do. Can
1 negative 2.
you explain it, please, Al?
I'm following this rule. I'm taking the Y coordinate here and I'm putting it in this first spot. And I'm taking the X coordinate, I'm taking the opposite of it, and I'm putting it in this Y spot. That's it. All right, what about the next one? We had B
That deserves a pass time.
at 6 comma 1. So what is the
1 negative 6.
1 negative 6? Do people agree with that?
Yeah.
And then how about, that's supposed to be C prime. C was at, what was C at?
6, 8.
Thank you, 6, 8.
So it should be
So
8
that's
negative 6. 8 negative 6.
8, negative 6. So what does it look like when you plot these? Have you grabbed these 3 points yet? Huh?
No.
Go ahead, I want to see what happens. Curious.
Oh, this is weird.
Whoa. Lone Audrey, a piece of graph paper.
Oh, I got you, Audrey. I'm already.
It's like flipped. But it's like, oh, sorry.
And there was this one, 8, negative 6. Interesting. I have.
Did you get something?
Interesting. What are we noticing about the rotation? Is it a rotation?
Yeah.
Because the arrow was rotated?
Yeah, looks like it turned and down.
Yeah, it definitely rotated.
All right, so we have just gotten ourselves a rotation mapping because this went to, what was it, 1 negative 2?
Yeah.
Let's see. 1 negative 2 is here. What was it? 6. 1 negative 6. Is that right?
Yeah.
And then what was it?
8 negative 6.
8 negative 6 is here. So this is A prime. This is B prime. This is C prime. So this guy just kind of rotated like this. It actually rotated 90 degrees about the origin. Is what we just. I guess I should clarify. We rotated 90 degrees clockwise or counterclockwise?
Clockwise.
Clockwise around the origin with that transformation.
Isn't
Isn't that cool?
Yeah,
That's kind of cool.
Was the origin C?
No, the origin is 0, 0.
Yeah, that's
Right. Okay, so what else do I have for you good people? So here,
What else?
was this a little bit overwhelming here?
No,
that's
I understand it very much.
No, don't even say that, Rachel.
So take a look at this.
I'm trying to not understand.
And thanks for watching, everyone.
Bye.